Hey everyone, today we're starting Unit 2. Lesson 0 is the review of some essential skills. So in this unit we're going to use what we know about lines, and we're going to start learning about different geometric properties to identify different shapes, and we're also going to take a look at circles and the equation of a circle. But for right now we're going to go over slope, which we've seen before. So remember that slope is the measure of the steepness of a line. It's basically the ratio of the vertical change in position as compared to the horizontal change in position. So when we say vertical change, we're really talking about a change in y. And when we're talking about a horizontal change, we're talking about our change in x, right? And so we've seen that before with slope, that we have our change in y over our change in x, which we'll write in that little equation square in a minute. And then finally, it's represented by the letter m. So if you need a minute to write all that note down, feel free to pause the video to write that information down. Okay, so like I said, m represents slope. Okay, lots of different ways we set up our equation for slope. We will often say that slope is equal to rise over run. We learned in our unit 0 about slope in terms of the y2 minus y1 over x2 minus x1. Another way to represent that is with this triangle symbol of next to our y. All of that's over our triangle symbol next to our x. And this triangle symbol is actually a Greek letter. Just make a note here. This is a Greek letter. And it's the Greek letter delta. It stands for change. So remember in that note we just said that it's the change in position of our vertical. So if we were to read this, it would be the change in y over the change in x. And the way we represent that with an equation is we say y2 minus y1, because that represents a change in my y position, divided by x2 minus x1. All right, we've seen lots of different slopes for our lines. So lines can have a positive slope. And remember, a positive slope just means that it moves up to the right. It can have a negative slope, so it can go like this, which means that the line is going to go down to the right. Some other slopes we've seen would be a slope of 0, which is a horizontal line. Again, we saw these in that review unit, unit 0. Or an undefined slope would be a vertical line. So these are the 4 scenarios for what a slope could be. So let's just review and make sure that we're all still comfortable finding our slope of a couple different lines here. So find the slope of each line. So this first line is AB. And when you see an M next to letters like that, it's just asking you to find the slope. So slope of line AB. So I'm going to grab a couple points here. I'm just going to grab the end points. Those seem to fall nicely kind of on the grid lines. So this point here is 2, 8. And this point here looks like 1, 2, 3, 4. So -4 and then up 2. So I'm going to use that slope formula I have up above, which is that y2 minus y1 all over x2 minus x1. And we'll substitute in those values. So my y2 is 8. And my y1 is 2. And then my x2 is 2. And my x1 is a -4. So I'm going to put that in brackets so that we can see we have a minus, a minus. And we subtract those. Well, 8 minus 2 is 6. 2 minus a -4 is going to change that to a +4. So 2 plus 4 is 6. So we can simplify that. So we can say that the slope of line AB is equal to 1. All right. Pause the video and see if you can do that for CD as well. Okay, so there's your solution there. Hopefully you identified some points and found that your slope is a -1/8. I just wanted to show you too that you could go the other way, and what I mean by that is if we decided to grab from point C first. So you can see that in the work here, we grabbed -3 first, which came from point D. And then we had to make sure when we moved down to our x that again we started with our point D, because we started with point D on the top. If we wanted to, we could start with point C though, and we should be able to get the same answer. So let's say this time I'm going to start with, let's grab a different highlighter. I'm going to start with point C this time, which means I'm going to have a -2 minus a -3. All of that I'm going to do over, and again I have to make sure I grab from the same point I did on my top. So I'm going to take the 0 this time, start with that, -8. Hopefully we'll work through this, you'll see you're going to get the same answer though. So -2 minus a minus is going to be a plus. So -2 plus 3 is going to be a +1. And then 0 minus 8 is a -8. So you can see no matter which one we start with in our equation, we're still going to get a -1/8 at the end of it. Okay, so calculate the slope of the line between the given 2 points. So I always find it easiest when you're given 2 points that we label those with our x1, y1, x2, y2. And then I'm going to use that same kind of denotion that you saw in the example above, where we have the slope of AB is going to equal our y2, so y2 is 4, minus my y1, which is 8, divided by x2, which is 11, minus my x1 of 5. Okay, so the slope of AB is going to equal -4/6. And we want to make sure we always reduce. So if we were going to reduce 4/6 or -4/6, we should be able to simplify that to a -2/3, right? We should be able to divide both of those by 2 to simplify. Go ahead and pause the video and see if you can determine the slope for example B. Okay, so using the exact same formula of that y2 minus y1 over x2 minus x1, hopefully we found that the slope of PQ is 3/1. Okay, so we've looked at finding the slope from a graph, finding the slope from 2 points. Now we're going to take a look at how do we find the slope if we're given, how do we find the equation rather if we're given the slope and a point that the line passes through. So it says that our slope is a -4 and it passes through the point 1, 1. So we're going to use that information to plug into our equation of a line. So we're going to sub in -4 for my m, because slope is simply our m variable in the equation. And we're going to take point 1, -1, and we're going to sub it in for x and y, right? Because if we have a point, the first part of the coordinate represents x, and the second part represents y. So remember, the equation of our line is y equals mx plus b. So substituting in for my y is a -1. In for my m, we said is a -4. And then I'll put some brackets to represent that multiplication happening between my m and my x. And then 1 for x plus b. So now we've substituted everything in. We're going to have to do some algebra to basically solve for b. So we'll keep simplifying and using our algebra to do so. So we can simplify our right side here. So -4 times 1 is a -4 plus b. I'm going to bring that 4 over to the other side by adding it. So we'll do a -1 plus 4 equals b. So 3 equals b. So now we have our y-intercept. We have our slope. So we should be able to use that information to write the equation of our line. So we'll say, therefore, the equation is y equals, and you want to substitute in your m value and your b value, which we found our b value to be 3. Okay, we're going to try this process again, but this time we're given 2 points instead of a slope and 1 point. So we're going to have to first try to find our slope. So first, find slope. So we know m equals, and we'll label these again, x1, y1, x2, y2. So my y2 is a -1, and my y1 is a -4. All of that's going to be divided by my x2, which is 4, minus my x1, which is -2. So -1 minus a minus is actually a plus. So -1 plus 4 is going to be 3. And the same is true in the denominator. That 4 minus a minus is going to be a plus. So you'll have 3/6. So we can reduce 3/6 to 1/2. So now that we have our slope, just like we did in example A, we're going to sub in m equals 1/2. And you can pick any point you'd like. I'm just going to write this a little bit lower. So we're going to sub in m equals 1/2. And we're going to pick any point, doesn't matter which one. I'll just choose the one with less negatives. So we'll choose that for -1. Okay, so into y equals mx plus b. So I'm just going to label that this is x, this is y. So in for y, I'm going to substitute a -1. My slope is 1/2. And my x is 4 plus b. 1/2 times 4 is 2. And then finally, we'll bring that 2 over now by subtracting it. So we'll have -1 minus 2 equals b. Let's finish up over here. So -1 minus 2 is a -3 equals b. So we can say, therefore, the equation is y equals, now we have to make sure we go back and take a look. Okay, what was my slope? What was my y-intercept? Those are the information that we plug in. So y equals 1/2 x minus 3. Okay, so lots of different ways we can work to get that equation of our line. The next thing we're going to take a look at in this note that we're going to need for this unit is Pythagorean theorem, which you would have seen last year. So Pythagorean theorem is a theorem or an equation that we use with triangles. So a couple notes to make about it. The triangle must be a right angle triangle. The longest side is across from the right angle, known as the hypotenuse. The sum of the squares of the two shorter sides is equal to the square of the longest side, or the hypotenuse. So we're just going to go through a couple of these notes here. If you'd like to take a moment to pause the video to write them down, we're then going to kind of show you what each of these bullets means with this triangle below. So take a moment to pause and write that note. Okay, so that first bullet point said the triangle must be a right angle triangle. So how do we know if it's a right angle triangle? Well, this square here in the bottom of a triangle is going to tell you that. Okay, so it represents 90 degrees. Okay, this little kind of upside down L indicates right angle triangle. So we can only use Pythagorean theorem if it has this little 90-degree symbol in the corner. Okay. The next point says the longest side is across from the right angle, known as the hypotenuse. So if this is my right angle, it's saying that the longest side has to be across from that. So it has to be across. So they're saying this side here must be what we call our longest side, or our hypotenuse. Okay, the last point there says the sum of the squares of the two shorter sides. Okay, the two shorter sides we're going to call legs. So we have this over here, we're going to call this a leg. And we're going to call this a leg. Okay, those two shorter sides are legs. And then we're just going to give them some letters. So we're going to call this leg A, and we're going to call this leg B. So what they're saying is that if we square those two sides, so if we take A and we square it, and we take B and we square it, the sum of those two squares, so A squared plus B squared, is going to be equal to the square of the longest side. So that longest side, which is our hypotenuse, we're going to call that side C. It's going to be equal to the square of that side. So again, I have to square it. So we're going to say a squared plus b squared is going to be equal to c squared. Okay, this is our equation for Pythagorean theorem that we should all get comfortable with. A squared plus b squared equals c squared. Remembering, the most important part is that this hypotenuse goes right here, and we're going to go over this a bit, and you're going to get some practice with it. But the hypotenuse is always c. You can place either leg for A, either leg for B, but the hypotenuse must go to C. So let's take a look at some examples and see if we can find those kind of unknown sides. So it says calculate the length of the missing side, round answers to 1 decimal. So remember, the hypotenuse is the first one that we kind of want to identify. The hypotenuse is always across from that right angle. All right, and then the legs are the other two sides. So we're going to label them with the appropriate letters. Our hypotenuse is always going to be C. Okay, and the legs can be A, B. It doesn't matter which one you call A and which one you call C. So 7 is equal to A, or sorry, 7 is equal to B, and A is equal to 8. And our hypotenuse is what we don't know right now. Okay, so Pythagorean theorem, and I just want to make sure we're comfortable. We can write it either way. We can say a squared plus b squared equals c squared, or we could say c squared equals a squared plus b squared. It doesn't matter which side of the equation you put the equal sign on. So now we're just going to sub in what we have. We don't have c squared, but we know a is 8 squared, and b is 7. So we can work to at least simplify that side of the equation. So 8 squared is 64, and 7 squared is 49. And if we add those together, we're going to get 113. Okay, so we've almost solved for C, but we still have this power of 2 on C. So we have to think about, how do we undo a power of 2? Okay, and in algebra, the way that we undo a power of 2 is we square root it. So if I take the square root of this, just want to make a note here that square root both sides to undo the power of 2. Okay, it's the opposite operation of squaring something, is square rooting it. So we're going to do that to both sides of the equation. So that'll leave us with C on the left, and the square root of 113 is going to be 10.6. Okay, we'll give that a try on the next question, making sure that we can identify which part of the Pythagorean theorem do we have here. Remember, we always want to identify that hypotenuse first, which is always across from that right angle. Even though this triangle is tipped sideways, don't let that fool you. The hypotenuse is always across from that right angle. All right, and then we'll call the legs A and B. Doesn't matter which one is which. So we have, again, a squared plus b squared equals c squared. So we don't have our a this time. B squared, so 6 squared, and 11 squared. So we'll simplify what we can. 6 squared is 36, and 11 squared is 121. I'm going to bring that 36 over to the other side by subtracting it. So 121 minus 36 is 85. So the same as last time, we have to undo that square root. We're gonna undo that square by taking the square root, and we'll just finish it up over here. So the square root of 85 is 9.2. Right? And especially with Pythagorean theorem, you're going to see that it's usually going to ask you to round to 1 decimal, but just pay attention in the question, what is it asking us to round to? And in this question, it says round answers to 1 decimal. That's all for your notes for today.